first for all the work that you do in that community in the US. Driving forces in the commercial drone market in the US, said differently, the vision of the European companies who are from Switzerland about what's going to push forward the market in the US in the coming months. And to me, it's already started. So let me just talk a little bit more about SenseFly so you realize who we are and what we do in Switzerland, but also in the US. We are a company that was created in 2009, a parent company since 2012.
One of the biggest UAV manufacturers with the Air drone and now the Bebop drone. And now we are about like 100 people in Switzerland and in the US. We've opened an office in Washington, D.C. and also a research center in Iowa for everything that is related to ag applications. We produce more than 100 EB each month in Switzerland. And now we're number one in terms of volume for fixed-wing mapping drones, at least in 2014. And right now in the US, every company applying for Section 333, getting an exemption, at least 1/3 of those companies choose to do it with the EB. There are many different reasons for that. One of them is we've tried to put together like a workflow that will help those people understand the Section 333 process and get an exemption really quickly. We have a different range of products, starting with the swinglet cam, and now we've developed the EB platform. The EB Ag is a slightly different platform, mostly for agriculture. And we've also released recently EB RTK with a differential GPS on it for survey-grade mapping. Just to give you a rough idea, with the EB RTK, we can produce maps with 1-inch accuracy, like vertically and horizontally. And all those platforms, they are mapping platforms, meaning that you can program the drone to accomplish a mission. It will do that automatically. Take pictures during the flight, and then we will just merge all those pictures together to create accurate 2D and 3D maps. We've also developed a wide range of sensors from a standard RGB camera to a brand new thermal camera, so we're adaptable to any kind of applications. The one I want to highlight, especially because we're in California, is also the multispectral camera. That multispectral camera is widely used for agriculture to create NDVI and also prescription maps. And coming really soon, our new product, we're very proud of it, especially because we've designed entirely in-house. Autopilot, the triple view camera that you can see the head of the exam. And actually we'll fly for the first time in the US next week at the AUVSI conference. So really looking forward to it. So back to my question, that was what's pushing the US market forward in the US? First of all, it's to me hardware and software companies that will actually supply the products. And here in the US, I mean, you're pretty lucky because you have the leading companies in the UAV technology. It started like a while ago with 3D robotics, and now you see players like Skycatch developing like a very nice platform for autonomous flights, but also people that are like kind of the operating system for drones, Airware. And all those companies, I mean, they're born in the US and they've been very successful so far. You have also in that country like people developing really nice sensors, like MicaSense. It's a company based out in Washington State doing a pretty good job creating sensors for agriculture. And you have software company like Skyward or Drone Deploy doing either like flight planning and processing, but also like everything that is related to the safety of the flight or insurance purposes. Like Skyward. And in top of that, you have like two worldwide companies that actually gave credibility to that market. Because Amazon first and then Google, they've said, like, yes, we see commercial applications with drone. And at that time, it changed everything, because everyone in that country realized that with drones, you can do something that is meaningful for the society, or that will just bring something more to your business. And we've seen, or at least at SenseFly, a lot of interest from people that actually realize that now you can do something with drones, and you can create value, and it's going to be the next complementary tool that you'll use for your business. To create a market, you need also people that will actually purchase your products. And here in the US, once again, it's really easy because you have a lot of mining and construction. And everyone knows now that drones can be used a lot for 2D, 3D applications. That's an example that we have from an extraction mine in Chile. I could give the same example here in the US. We have also in the US a lot of agriculture. And I mean, everyone knows that today in the Midwest, like the price for the corn is like sinking. So farmers look for a new tool to be able to become more efficient. And drones are one of the answers for that. And companies in the US, they've looked into that specific market because there are a huge number of farms in the US, but also a very large economic impact. AUVSI stated in 2012 that it could be as much as 80% of the global UAV market. What we do right now for agriculture is water and nitrogen management, insurance claims, yield predictions and index maps, but also prescription maps. We've just released a new feature in our software that is actually powered by Pix4D to go from the drone to the tractor instantaneously, meaning that right after a flight, in 15 minutes, you're able to generate a prescription map that you can load into your tractor to put fertilizer or water, whatever you want to. And finally, I want to take two examples of applications that we see right now in the US. And the first one is actually, and I'm pretty proud of it, and I want to thank the University of Hawaii, but also the FAA to make that happen. It was a damage assessment that we've done using one of our drones in Hawaii after the eruption of the volcano on Big Island. It was last year. And we've used one of our drones to map in 3D the area and do some estimation on what happened, but also building those 3D models to do predictions on where the lava flow will go next. So helping the people doing all the rescue management. And on the right, it's a project that is led by a Swiss association called Race for Water. And those people, they use the boat that you see here to do a worldwide tour to map plastic debris on the ocean. And we're going to use the exemption that we received from the FAA to help those people doing some surveys in Hawaii and make people realize the impact of plastic debris on the coastal area in Hawaii. Okay? So you see a lot of applications. I've just talked about the one that I know. I'm sure you have so much imagination that I would not even know what you have in mind if I put a UAV in your hands. But anyway, at least that's something, and many people cover those applications already. Finally, to create a successful market, you need regulations. And I guess Patrick was right. We need regulations. As manufacturer, we need standards to comply with. As a user, you need to know what you can and cannot do. And my take on that is that the FAA did a wonderful job with the NPRM and offer right now in the US a very nice transition period with the Section 333. So just to summarize that, and I don't want to talk too much about regulations since we have a specialist next, But at least right now, the FAA made it really simple when you have an exemption to fly with the blanket COA. And that's something that is really nice because it's also business driven, which is the most important. And if I translate that regulations concept to Europe, there is actually something really interesting. And that's a quote from the European Commission that states that the integration of AirPass or UAS will be based on the principle that you'll have an equivalent level of safety as manned aircraft, meaning that one operation with a drone should be allowed if you can state that you're going to reach at least the same level of safety as a manned operation. And in the US, you have pretty good researchers, pretty good math people that actually from the MIT proposed a method just to compute that and calculate the equivalent level of safety of a drone operation. So if you look at the average value for manned operations, which is about like 10 minus 7 fatalities per hour of flight, you can compare right now the safety of a drone operation. Now let me take that example for ground impact hazard analysis. So that's the formula that is widely used in Europe now to determine an equivalent level of safety. So based on different things like the population density, of course, but also the probability of penetration of the aircraft, depending mostly on the kinetic energy, so speed and weight, and also the area of exposure, like the wingspan of the plane. And as a manufacturer, what we can monitor when we design a product, or at least when we check for the continuous airworthiness, is the mean time between failures. Like how much my plane will crash when it's in operation. And that MTBF is something that could be used by the civil aviation authorities to determine the standards. Because if you say I want to have the same level of safety as an aircraft, then the ELS is fixed. So you can determine what MTBF you need to be as safe as an aircraft. Just to give you, a quick heads up on how you can minimize the ELS, and I guess that's important so you'll realize why most of the countries, they've actually put a specific regulation under 2 kilograms. If you're light, you're gonna have like a very low kinetic energy, and basically you're gonna increase the equivalent level of safety. But also something that is really important, and that's probably my only comment on the NPRM right now, we can rely on the artificial intelligence of our autopilots to manage critical situations. Even if the human is still in the loop monitoring what happens in flight, today most of the UAV companies, or at least the commercial UAV companies, they've achieved a programming of the autopilot that guarantee the safety of the operations. So it's important to keep in mind that most of the systems right now, they're automated and not manually controlled, or at least non-directly manually controlled, and it should stay that way. Because that's the autopilot and all the safety features that we put on it that could actually lead us to that equivalent level of safety for the EB, which is like for an agricultural operations over a low density area, 10 minus 9, 100 times safer already than a manned operation. Interesting results in the US, and actually I did not make all those calculations, found that article on the MIT study. If you take a 1 kilogram UAV, you can crash that UAV on the ground every hour on 95% of the territory and still be as safe as an aircraft. And I'm talking, of course, about the fatalities on the ground, okay? So that's important to realize that the main challenge right now, it's mostly like the reduction of mid-air collisions, okay? But still, for that, once again, the manufacturers, they thought about it. And we agree that in the first step, visual line of sight operations should be the one that, start that industry. And we have some tools built into our flight management software to avoid that kind of situation of mid-air collisions to happen. You can just click on one button and the UAV will automatically come back to a safer place, closer to the ground, or just change its trajectory. So that's something that we all need to keep in mind, that today we already have the tools to make those flights safer. And why not? And that's just kind of proposals that are correlated to that level of safety notion. Why don't we do in the NPRM or in the next rules to come, extended line of sight operations for aircraft that actually are as safe as manned aircraft? Why don't we remove the requirement for manual control of the aircraft under the micro UAS class? Because every UAV that fly right now has kind of automation in it. However, what we like in the NPRM is that proposition of micro UAS class, because to me it symbolizes well that equivalent level of safety notion. And we have the fact that the FAA said that we do not need any manned aircraft pilot skills, because it's two different things. And today it's very different to operate a micro UAS and an aircraft, obviously. Finally, impact of those regulations. I wanted to take that example of France because it shows you two things. The one is that France came with the regulation in April 2012. Now we have more than, 3,000 drones flying in France for about 1,500 operators. Today in the US, or at least in April 2015, 145 exemptions were granted by the FAA. It shows you that the US are not behind other countries. Still a little bit behind, but growing very fast. And that's something that was actually very important, and I guess everyone should congratulate the FAA for that, is to make that Section 333 process very streamlined and very easy. You should go on the FAA website and look at all the documentation about the Section 333, that's pretty clear. And then we're gonna have regulations finally in the United States, and it's gonna ramp up even faster. But just keep in mind that it's already going on, and if 10,000 jobs are created in France in 2020, how many jobs will be created in the US? 100,000, 500,000? So that's gonna be huge, and it's already started. Thanks for your attention. If you have any questions. Thank you. Yeah. Okay.
In your regulations portion of the slide, you mentioned the European position, which is the integration of RPAS will be based on the principle that all operations will have an equivalent level of safety in comparison to regular manned aviation. How does that apply to the A10 certification, the ASTM use in the United States that we have to certify an airframe? To date, Patrick, I'm not sure if a military airframe has actually even met that ASTM standard. They've all been waived, I believe. So if you can't actually certify a Predator, or a global hawk is airworthy through ASTM, which is the manned aviation certification process here in the US, how can you guarantee the same level of confidence for a small system?
Just because based on that equivalent level of safety model, you can actually waive the airworthiness requirement.
You're saying wave, so not truly parallel, but waived.
But wave, yes. I mean, and the same for the software. Like, we will not, or at least that's my position, you do not have to require the same principles for software certification for manned aircraft, for unmanned aircraft, if you reach already an equivalent level of safety.
Why have an equivalent? I mean, there's a standard right now. So the difficulty there is there's an existing standard.
But that apply for manned aircraft. But you cannot apply the same for unmanned aircrafts. You have to define like some different standards that may actually match that concept. And what Europe is doing right now is telling civil aviation authorities, look, we have that equivalent level of safety concept, so please define best practices of standards that can match that, because you're not going to request the same thing for a UAV weighing like 500 grams than something that weighs 150 kilograms. And if manned aviation standards could apply for that 150 kilograms UAV, those ones cannot apply for small UAVs because you want it to become, to remain like pretty cost effective. Thank you.